All right, so a lot of us are struggling on this predicting double displacement. Some of us have got it figured out pretty well, but there's several steps, and I think that's what's bothering a lot of us. So remember, our steps are, who are we going to compare? Who has an H in it? So you have to do the H second. You can't just go W-O. So who are we going to compare? Then is a reaction going to happen? Right? So I know a reaction is going to happen if I make something that decomposes, water, or an insoluble thing. The most common thing is something insoluble. And then predicting the products correctly, right? So good idea. This should be probably the third of those videos that you've watched. You should have tried some of these already. So good idea to pause me and work ahead on here. So who am I going to compare, right? So I need to be able to recognize my parts. So there's only two parts. So I specifically grabbed some that had a bunch of pieces because that seems to be what's given some of us some trouble is where do we break it apart? So read that polyatomic ion list. I'm going to bounce a little bit there, right? Read through this list and get to know those a little bit. That'll make life easier. And also recognize there's only going to be two parts. So if I don't immediately recognize something, look on here and see what it is. So when we look on here, we see we've got chromate is CrO4. And so you've got magnesium chromate and you've got silver chlorate, ClO3. That's another one, right? So that's where I'm going to break those in half there because these are our cations and these are our anions, right? So the ones that I compare the inside two and the outside two, right? The positive from here with the negative from here, and the positive from here with the negative from here. I know it's all a negative positive, right? I'm going to compare the insides and the outsides because I want one positive and one negative in each of my new compounds. So change some color here a little bit. So I'm going to compare magnesium and chlorate, and I'm going to compare silver. Let's do that on top. Silver with chromate. Right, so you silver chromate and magnesium chlorate. So pause me again if you haven't already done that and figure out if either of these is insoluble, water, or something that decomposes. So when we do that, right, you go down to magnesium, over to chlorate, we see that this is soluble. Magnesium chlorate is soluble. So I can use an S for soluble there because that's not a compound. That's just a note to me. But silver chromate is insoluble. So if that's insoluble, I'll put an I right here for that. Now that's just the notes to me. I need to translate that when I'm actually writing my formulas, right? So so I know who to react. We did that part. We know a reaction is going to happen. So that part's done. Now I just need to put the right products together. Now when we bring them across with their charges, not with their subscripts. Now I'll leave my thing together. Chromate is CrO4, so I'm going to leave it together. Since that's the insoluble one, I'll write it first. So I think charges when I put it together. So the two pieces are Ag and CrO4. The charges for those two, silver gets a +1 charge. Chromate, you can see on the back of your periodic chart, if you look in your polyatomic list, chromate gets a -2 charge. So I can't just have AgCrO4, I've got to have Ag2CrO4. I need two of those silvers to balance that out. And then, right? That was our insoluble one. So the way that I show in a reaction that something is insoluble is either with an S for solid or a down arrow. I like the down arrow because I don't want to confuse it with S for soluble. So I'm going to say, well, that is insoluble, like so. Right? And then the other piece, the aqueous piece, the piece that's dissolved in water is magnesium and chlorate. Right? So magnesium and chlorate, that was soluble. So that stayed dissolved in water. So we wouldn't see this get made. But it would be MgClO3 would be our two pieces. And then I think charges, right? I don't know if we can see that well enough. Magnesium is in column 2, so it gets a +2. Chlorate gets a -1, so it's MgClO3, 2. And that's aqueous, so we put an AQ by it, right? And then I come back and I erase my charges so that I don't confuse myself with that. So once we put them together, we've got to think charges. Don't bring their subscripts across. There was only one chlorate before, now there's two, right? But that's because silver was only +1, but magnesium's +2, so it'll form a slightly different compound, right? Let's go ahead and do one more. Let me pause it real quick so you don't have to see me write an array. So with this one, we've got nitric acid, HNO3, and potassium carbonate, K2CO3. Again, we've got a couple polyatomic ions there, so figure out who, then form your new comp, then figure out if a reaction is going to happen, and then form your right product. So again, pause me and work ahead on that. So I'm going to put the insides together, potassium and nitrate, and compare those. And I'm going to put the outsides together, hydrogen and carbonate, and compare those. Potassium and nitrate are soluble on our solubility chart, and there is a dash for hydrogen and carbonate. Hydrogen and carbonate, or hydrogen and hydrogen carbonate, are all going to make the same thing. That's going to make H2CO3, because carbonate's -2, so you'll need 2 hydrogens to balance that out. And that's the one decompose when we have to memorize. Remember, this is going to break down. We saw this in our lab. We've seen this a bunch of times already this year. This is going to break down to H2O and CO2. So in my products, instead of writing H2CO3, I like to actually write it and then cross it out, but you don't have to. I like to basically put this up here, but I'm just going to go ahead and say H2O liquid and CO2 gas. And instead of putting a G for gas, I'm going to use an up arrow, because that reminds me that that's a driving force of the reaction and that it's going to bubble up out of the solution, right? Because it's a gas. So that's this part. That's the one decompose when we have to have memorized for our double displacement stuff. And then our potassium with our nitrate. And whoops, I didn't do a different color with that or anything, but potassium with nitrate. And again, I put it together, a K and an NO3, because those are the 2 pieces. And then I think charges. Potassium gets a +1. Nitrate gets a -1. So it's just going to be 1 of each. So potassium nitrate is just going to stay dissolved in water and be a 1 of each on that. Right? KNO3. Hopefully that helps. Be real systematic about it as you do it. It's a lot to keep track of, but it's an important skill for us. And the more of those you practice, they do start to get easier on you there.